Hello everyone, I am K Harshit. In my previous video, we have learned what is an alkene, what is an homologous series, then what are the characteristics of homologous series. Now in this video, let us learn unsaturated compounds. And the flowchart that we have drawn, we have completed the saturated compounds, that is alkenes. Now we are left with unsaturated compounds, that is alkenes and alkynes. Now today in this video, we will learn about the unsaturated, first unsaturated compound, that is alkenes. Now let us just have a gif. Alkenes, it has at least one single one double bond, one double bond. The general formula for alkenes is CnH2n. Then how do we represent? We represent like this: C double bond C. Now let us see how will we get the structural formula, the electron dot structure of the alkene group, and then the IUPAC names given by the International Union of Pure and Applied Chemistry to the compounds of alkenes. Fine. So how I have made for alkenes, I am doing the same even for alkenes also. What is the general formula of alkenes? It is CnH2n. Now I am taking N as 1. What would be the compound? C1, H2 ones are 2, CH2. Now when I draw the structural formula, 1C, and then it will be a double bond, right? Because it's an alkene. Okay. I am putting a double bond to H. One more H is left out. Here I am putting one more H. Is the tetravalency satisfied here? Tetravalency means what? Another bond should be there. It means it requires only 4 bonds. But here you see 1, 2, 3, only 3 are there. But another is required, right? So we don't have another bond here. Which means we cannot have alkene as CH2. We cannot start the alkene group from CH2. The first, we cannot start the alkene group with the value of N as 1. Now let us try with the value of 2, would we get or not? 2 means C2, H, 2 into 2, 4. 2 carbon atoms. Carbon, carbon. Alkene group. Double bond. 4 hydrogens. Here 1, 2. So more 3, 4. Here 3, 4. If you see, here the tetravalency is satisfied. You are having 1, 2, 3, 4 bonds for this carbon atom, 1, 2, 3, 4 bonds for this carbon atom. Done? Now, coming to the condensed form, it would be in this form: CH2 double bond CH2. Now, let us draw the electron dot structure for the same. C will have 2 here and 2 here because it's forming a double bond right here. So 2 there. And then this carbon would also have 2 here, 1 here, 1 here. And 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. Remember, whenever you are having a double bond between C and C, then the double bond represents there are totally 4 electrons in the middle of the 2 carbon atoms. Now draw these cross circles. H is satisfied with these 2. Here H is with this 2. Here H is with this 2, and here H is with this 2. Done. H story is done. Now coming to carbon, 1, 2, 3, 4, 5, 6, 7, 8. Like this. For this carbon, 1, 2, 3, 4, 5, 6, 7, 8. Like this. Done. So now count the carbon electrons. 1, 2, 3, 4, 5, 6, 7, 8. Done. 8 are done. For this carbon, 1, 2, 3, 4, 5, 6, 7, 8. 8 are done. For hydrogen, 1, 2. This hydrogen, 1, 2. This hydrogen, 1, 2. 1, 2. Done. Now comes the IUPAC name. If in alkanes, if we are having N as 1, we took the IUPAC word root as neath. But here as N is not possible, so we did not get the name as neath. We directly start with eth. So here as the N is 2, we have the word root as eth. We have the word root as eth, and the suffix would be from the name alkenes, ene, eth, ene, which means it would be ethene. It would be ethene. Now let us try with NS3, NS3, C3H, 2 3s are 6, C3H6. Structural formula 1, 2, 3. Is this correct? No, because we need to have double bond only between one carbon atom. It may be here, or you may even put it here also. I have put it here. Now draw the hydrogens 1, 2, 3, 4. For this 1, 2, 3, 4. This 1, 2, 3, 4. Now you see the count the number of hydrogen atoms. 1, 2, 3, 4, 5, 6. C3, 3 carbon atoms, 6 hydrogens. 1, 2, 3, 4, 5, 6. 6 hydrogens. Done. The condensed form for this would be CH2, double bond, CH, single bond, CH3. Done. The electron dot structure again, it would be C. I have put double bond here, so it will come 4 electrons. C here, then 1 electron for this and 1 electron for this carbon here. Now 1 hydrogen you have put here, right? So 1 carbon bond, 1 hydrogen electron. Then I have even put hydrogen here down chain. So even here 1 electron, 1 electron of hydrogen. So here we have satisfied hydrogens. Now here 1 hydrogen for the central carbon atom. So 1 valence electron from 1 electron from carbon and 1 from hydrogen. Even this hydrogen is also satisfied. Coming to this 1, 2, 3. 3 electrons are left, right, for this carbon. So I am satisfying it. H, H. This is satisfied, this is satisfied, this is satisfied. Now carbons you draw 1, 2, 3, 4, 5, 6, 7, 8. This is 1 bond. For this 1, 2, 3, 4, 5, 6, 7, 8. For this 1, 2, 3, 4, 5, 6, 7, 8. Done. This is the electronic dot structure for the third member in alkene series. Now the name, the word root would be prop and the suffix would be ene. So the compound would be propene. Now in homologous series, do you remember the homologous series which I have explained in the previous class or the previous video? It's nothing but it's the series which are having same general formula but different structure. Now you see here the general formula of alkenes is CnH2n. Now if we see this, the general formula of these three which I have taken is CnH2n. Perfect. Now what was the first characteristic in that homologous series of alkanes? We learned that they differ by a unit of CH2 and 14 AMU in alkane series. Let us see whether the same condition would be applied even for alkenes also. Now I am taking the first carbon atom here, CH2, that is, sorry, not CH2. C2H4, C2H4, I'm so sorry, C2H4. No, this is this is CH2 only. Here is C2H4, and I'm taking C3H6. 3 minus 2, C, 6 minus 4, CH2, right? We got the same here. As you can see, we got the same difference, the same unit difference for alkanes and even alkenes, CH2. Now let us check for the atomic mass. Now C2H4 means 12 into 2 and 1 into 4 plus, and then here 12 into 3 plus 1 into 6. Now 4 plus 4 8, 28, 6 minus 6 0, 30. Are we getting the same? Are we getting the same here? So here it's 36, I'm sorry, here it's 36 and here it's 28. Now 28 minus 36 minus 28, we are getting it as 14 AMU again. So here if we see 6 6 12, I'm sorry, here again addition mistake, 6 6 12 and then 42. Right now when we subtract 42 28, are we getting the same? 4 here, 1 here, we are getting 14 AMU. I'm sorry, I've done a mistake here. It's 12 is 36 plus 6 42. 42 28, we get the atomic unit, atomic mass unit as 14 AMU. Now we are getting the same difference in alkane, in homologous series of alkanes and in homologous series of alkenes. Means in alkanes and alkenes, the homologs differ by unit of CH2 and the atomic mass unit of 14 AMU. This is the first character. The second character would be the same. They would be having the same chemical properties but different physical properties. And as the number of carbon atoms increase, the melting point, boiling point also keeps on increasing. Done. So I hope you have understood the alkenes, the unsaturated compounds, alkenes. Now only we are left with alkynes, and which I will be covering in the next video. Thank you.